Greetings, programs. Welcome to Rationality From AI to Zombies, Chapter 38, Positive Bias, Look into the Dark. I am teaching a class, and I write upon the blackboard three numbers, 2, 4, 6. I am thinking of a rule, I say, which governs sequences of three numbers. The sequence, 2, 4, 6, as it so happens, obeys this rule. Each of you will find on your desk a pile of index cards. Write down a sequence of three numbers on a card, and I'll mark it yes for fits the rule, and no for not fitting the rule. Then you can write down another set of three numbers and ask whether it fits again, and so on. When you're confident that you know the rule, write the rule down on a card. You can test as many triplets as you like. Here is the record of one student's guesses. 462, no. 468, yes. 10, 12, 14, yes. At this point, the student wrote down their guesses at the rule. What do you think the rule is? Would you have wanted to test another triplet? And if so, what would it be? Take a moment to think before continuing. The challenge above is based on a classic experiment due to Peter Watson, the 2-4-6 task. Although subjects given this task typically expressed high confidence in their guesses, only 21% of subjects successfully guessed the experimenter's real rule, and replications since then have continued to show success rates of approximately 20%. The study was called On the Failure to Eliminate Hypotheses in a Conceptual Task. Subjects who attempt the 2-4-6 task usually try to generate positive examples rather than negative examples. They apply the hypothetical rule to generate a representative instance and see if it is labelled yes. Thus, someone who forms a hypothesis, numbers increasing by 2, will test a triplet, 8, 10, 12, hear that it fits, and confidently announce the rule. Someone who forms a hypothesis x minus 2, x minus 3, x, will test a triplet, 3, 6, 9, discover that it fits, and then announce the rule. In every case, the actual rule is the same. The three numbers must be in ascending order. But to discover this, you would have to generate triplets that shouldn't fit, such as 20, 23, 26, and see if they are labelled no, which people tend not to do in this experiment. In some cases, subjects devise, test, and announce rules far more complicated than the actual answer. This cognitive phenomenon is usually lumped in with confirmation bias. However, it seems to me that the phenomenon of trying to test positive rather than negative examples ought to be distinguished from the phenomenon of trying to preserve the belief you started with. Positive bias is sometimes used as a synonym for confirmation bias, and fits this particular law much better. It once seemed that phlogiston theory could explain a flame going out in an enclosed box. The air became saturated with phlogiston and no more could be released. But phlogiston theory could just as well have explained the flame not going out. To notice this, you have to search for negative examples instead of positive examples. Look into 0 instead of 1, which goes against the grain of what experiment has shown to be human instinct. For by instinct, we human beings only live in half the world. One may be lectured on positive bias for days, yet overlook it in the moment. Positive bias is not something we do as a matter of logic, or even as a matter of emotional attachment. 2-4-6 task is cold, logical, not effectively hot, and yet the mistake is subverbal, on the level of imagery, of instinctive reactions. Because the problem doesn't arrive from following a deliberate rule that says only think about positive examples. It can't be solved just by knowing verbally that we ought to think about both positive and negative examples. Which example automatically pops into your head? You have to learn, wordlessly, to zag instead of zig. You have to learn to flinch towards the 0 instead of away from it. I have been writing for quite some time now on the notion that the strength of hypothesis is what it can't explain, not what it can. If you are equally good at explaining any outcome, you have zero knowledge. So to spot an explanation isn't helpful. It's not enough to think of what it does explain very well. you also have to search for a result it couldn't explain. This is the true strength of the theory. So I said all this, and then I challenged the usefulness of emergence as a concept. One commenter cited superconductivity and ferromagnetism as examples of emergence. I replied that non-superconductivity and non-ferromagnetism were also examples of emergence, which was the problem. But be it far from me to criticize a commentator. Despite having read extensively on confirmation bias, I didn't spot the gotcha in the 246 task the first time I read about it. It's a subverbal blink reaction that has to be retrained. I'm still working on it myself. So much of a rationalist skill is below the level of words. It makes for challenging work in trying to convey the art through words. People will agree with you, but then in the next sentence, do something subdeliberative that goes in the opposite direction. Not that I'm complaining. A major reason I'm writing this is to observe that my words haven't conveyed. Are you searching for positive examples of positive bias right now? Or sparing a fraction of your search on what positive bias should lead you to not see? Did you look towards light or darkness? Here ends chapter 38. Now for my thoughts. Okay, so this is one of the better ones that showed up in Harry Potter and the Methods of Rationality. Harry, in that, tries to teach this one to Hermione. And she doesn't get it the first couple of times, but eventually she does catch on. She eventually learns to find something that should disprove her hypothesis, look for things that would prove it wrong. And she does quite well. And I must admit, from my own life experiences, I have learned to do something similar, not identical, but similar, in that when I have come up with a theory or explanation, I try to imagine what my almost built-in imaginary friend Blair, who is based on a real friend Blair, it's more a sort of an instinct he gave me by basically picking holes in every damn thing I ever said or did. Thank you, Blair. But thanks to that, whenever I come up with an idea, I usually then say, okay, now if somebody wanted to make me look stupid and prove that I was a complete idiot, what would they say? What questions would they ask, and how would they prove me wrong? Not exactly the same, but similar, certainly. And I think if I was asked the 246 question now, and unfortunately it won't work in its original form because I have encountered this myself, first through Harry Potter and second through this, then I would at least try to come up with some crazy results and see what they said, yes or no, like, -5, 0, and 4,000,003. And just to see what got you a good enough yes and no pattern so that you could actually work out the shape of the problem, rather than just getting a whole bunch of yeses. Because as Eliezer has said, if you get nothing but yeses, you really don't know anything. It's not until you get some no's that you actually find out which the edges of the problem actually are. That having been said, if everything you say is no, then it's just as bad. But yes, everybody needs a friend like Blair, who picks holes in every damn thing that they say. Sure, it can be kind of annoying at the time, but once you have learned the habit of covering your ass from every damn thing that you say, it becomes an instinct. It does at least help you to try and stop you shooting your mouth off until you actually know for certain, or at least close enough to it, what you're doing. And it also prompts you to look for problems. Like, okay, now we've got this plan, how could I possibly screw it up if I was a bad guy? And then look for that. Or how could I possibly screw it up if I was an idiot? That kind of thing. Not exactly the same, but along the same lines, I feel. That's all for now. Tune in next time for Chapter 39, Lawful Uncertainty. Bye for now.